I suddenly forgot all my Python knowledge. So I want now you to tell me what to type, okay? Because I just know how to type it, but I don't know what to type. So this is our program, and we want to write a program for this. Just to make it more easy, I just copy paste those statements as a comment here, so that we can follow what we have to write in a much easier way. So I want you to tell me what should I write. The program basically says, okay, we have to prompt the user some numbers, input three numbers, and then we'll take the sum of it, and then we'll take the average of it, and then we'll check the average. If it is greater than 60, we'll print pass, otherwise we'll print false. So, okay, what should be our very first line? First grade. Yes, so we have to define a variable name, first grade, and then? Not. What is it? I didn't understand. A-L-O-T? Oh, I see. In the lab, did you use this one, this code? Or you are coming from a different programming language background? Okay. So basically, yeah, we have to get the input data from the user, but in this slide we have seen which function is that to get an input from the user? I don't hear. So basically, I have to prompt the user to enter some value. So I need to ask user to enter some data. What was it? Input. Yes, so we have to use this input message. F-O-U-T. Is it to float? Oh, I see. I think I got. I heard F-O-U-T, then that's why I said that. Okay, sorry. Float, yeah, I'll come to this. Float is also, yeah, we have to use that also, yes. We can say enter any your first grade, so maybe we can ask it. But it will return the data as, in what type? String. But we have to do some operations like summation and take the average. So we have to convert it to integer or float. So the question doesn't specify that. Any of them can be fine. If you want to convert it to int, what should I write? int for that, and then we have to do this. But if you want to convert it to float, then as your friend said, yeah, we have to convert it to float. Yes. Then, okay, what should I do? We have done this part, which is, okay, this is done. Then I have to ask the user to enter the second grade. What should I do? The same as this one. I want, yeah, I need to change the variable name, and probably I need to change my message. And I guess for the third one, yeah, we will do the same thing. I'll just do the copy paste, and maybe we'll have third grade here, third one here. Now I want another student's input here. So we did this, and we did this. Now we are here. Calculate the sum of 3 grades. I want another student to answer. What should we do next? Calculate the sum of 3 grades. What is our first step? Define a number. So we should define a variable name. What can it be its name? X. It is fine. Yeah, we can define it. It is valid. But usually we'll try to give a meaningful names for that. Okay, so what should be a good name for it? Total grade, sum, yes, any of these will be fine. So total grade will be, then what? Then what will we do? Yes, first grade plus, so we will use our basically variables. First grade plus second grade plus third grade. Yes. All right, we also did this statement. Then we should calculate the average. What should we do then? Another student, please. Now we are at this step. Calculate the average of 3 grades. Yes, please. Over 3. Yes, this is 1, 2. But is there anything missing that we did? I think. Yeah, I need to define one more variable for that, so that I have to keep all my data in some place in my memory. That's why I'm keep saying this. Average grade is total grade by 3. Is it so since we have float numbers and we are doing float division? All right, now we also did this part. Now here we are. Use an if statement to check if the average is greater than 60. Can you say it again, please? Yes. Then 60. Yes, but we have one more part here, right? What is it? There's some missing. Now we have to follow the notation. So now this will be an if statement. If, yes, then this part is correct. And then I should do one more thing. What is here? Yes, double column. Then, okay, now I actually did this part. Use an if statement to check this part. I did this, so I'll put also here done. Then, if the average is greater than 60, print pass. So basically, should write print pass here. Then, okay, now I'm here. What should I do? Yes, again with an if statement. Yes, perfect. Is my typing correct? Yes, exactly. Now, my code basically is not correct. Why is that? What I'm saying here is, if average grade is greater than 60, then do this, print pass, and check if it is less than 60, and then print fail. But if it is not, do nothing. This is what I'm saying. So in order to fix that problem, again, I need to check my condition, and I need to put here double comma. Yeah. Then it will be correct. Now it is fine. Now what I'm saying is, okay, if average grade is greater than 60, print pass. If it is less than 60, print fail. Okay, so let's also run it now to see. My grade is 40, 50, and 40, then yeah, fail. If my grades are, I don't know, 60, 70, 80, and 100, then pass. But we are not covering everything in these if statements. What is that? Equal, yeah. What if a student got 60? Like if my scores are, if my average is 60, like all my grades are 60, I didn't either pass or fail. So I should change my code. What should I do here? Yes. So, I mean, this was a misleading statement. Now, this is a much more realistic case that for our code. All right, perfect. I'm going back to my slides. Do you have any question about this part? All right, then let's move on. This code is pretty similar to what we did. We just have this high score variable at the very top, which is 95. Then we ask the user to enter 3 test scores. We just convert it to int instead of float. Then we take the average. We can also do it in one line, like do the summation and then divide it by 3. And then it prints the average. And then if it checks if the average is greater than or equal to our high score, which is 95 at that point, then it will print this congratulations messages and so on. Now, if else statement. So what is that? Uh, Software developers are actually pretty lazy people. Lazy in typing. We are not lazy in trying to find a good solution for sophisticated problems, but we don't like spending our time to type a message, type something, okay? And we also want to make our code as simple as possible. I don't want to make my complex unnecessarily complex, unnecessarily hard to read and so on, okay? So that's why we have all these in many cases we have some statements that can be written in a long way, or there's just some shortcuts to write to express the same thing. And else statement is this also. Like when I write a condition, if I have two possible paths of execution, like when your robot is going, if there's an obstacle, then turn right. If there's no otherwise, move forward. So I have two options. I can either move forward or I can turn right or maybe turn left, whatever it is. So I have these two options. But it only depends on whether there's an obstacle or not. So for those cases, again, I have this if-else statements. If there's an obstacle, do this. Else, which means like otherwise, if there's no obstacle, then do the other thing. So this is called if-else statement. We have basically in the other one, like if the car engine is not working, start the engine. It was one-way option. But here now, when you are driving, like I don't know, if there's a cat in front of you, then hit the brake. Otherwise, you can just continue, for instance. So I have two different options. Or maybe, if you want to go north, then turn left. Otherwise, turn right. Maybe. I have, again, these two possible options. For those cases, we have these if-else statements. But now, we also have to follow some strict syntax. Again, we have this if condition, and we have the statements that are indented. Then, I just explained what it should be done if it is not correct. So else is also a keyword. So I cannot give a variable name with the name else. And I put this double column. And then I put some more statements that are indented. So when I do this, what happens is that I say that you either run this or that. But both of them cannot run together. Both of them cannot run together. Like if there's an obstacle, I cannot turn right and move forward at the same time. I should do only one of them. So this is also, I know that only one of them will be definitely executed. Either this one or that one. So this part is also important to know. Like when I have this condition is true, I know that this part will be run. If it is, and then what will happen is I will check the condition. If it is true, I will run it. Then when I come to here, I will jump to here. I will just skip this else part. I will not run it. So only this part will be executed. But if the condition is false, then I will jump all the statements and come to this else part, and then I will execute this part. So I either run this part or this part, and then I will continue. Then once it is done, I will continue from this, continue my execution from this point. Again, just as an example, now we have a condition. If it is true, we will run this block of code. If it is false, we will run this block of code, and then we will continue our execution at the end of each passage. Like if score is greater than or equal to 60, print pass. Otherwise, print failed. If it is balance is greater than or equal to pay amount, then update the balance and print your new balance. Otherwise, print not enough money. So I have these two different conditions. And in my code also, now, as I said that the main thing is I don't like typing. I don't want to make it harder to read and so on. So instead of writing this way, like if average grade is greater than or equal to 60, print pass. If average grade is less than 60, print fail. What I could also write is, instead of saying this, I would say this part, else. And they are exactly the same code. They will uh, do the same thing exactly. Uh, and actually, this is more natural in English. Like, if I would say this, like, if a student gets 60 or more, she should pass, otherwise she should fail. Like, I don't say that, okay, if a student gets more than at least 60, she passes. But if she doesn't get 60, then she fails. I usually don't say it, like, because again, I'm just reiterating my condition. I don't need it, so that's why I can also write exactly the same thing like this. If average grade is greater than or equal to 60, print pass. Otherwise, which means average grade is not greater than or equal to 60, then print fail. This is just, again, a visualization. Like, if we set first x is equal to 4, then we check if it is greater than 2. If it is true, print bigger. If it is false, then print smaller. But I will either run this or that, and then I will continue my execution from this point. Okay, I have 7 minutes. And when we are talking about comparison, it doesn't always have to be numbers. We can also compare strings, and that might sound pretty weird. Like, I can literally say in my Python code, if red is greater than blue, okay, then print red is greater than blue. Okay, that would sound weird, I know. Else, maybe it's not the case, I would say blue is greater than red. So now you might find this very weird. Like, what do you mean by this? Like, and I will delete this part first, just not to confuse our output, and then I will run it. So it says red is greater than blue. What is this? Like, how can you compare colors? That doesn't sound reasonable. The thing is, in our memory, actually, in the computer, everything is kept in terms of bits, ones and zeros. Everything is kept as a number, actually. When I say, when we print a message like a Mary and so on, or any string, what is actually happening is, in the computer, there's an encoding. Like, how can I keep the value of m, like with ones and zeros? Eventually, it should be like a number with ones and zeros. I don't have this kind of a. I cannot keep m actually. What we do is that we have this ASCII character. What is ASCII? ASCII means American Standard Code for Information Interchange. So for each character, actually, there's a number assigned. Like, for instance, 77 means capital M. 97 means lowercase a. 114 means lowercase r. When Python is processing that data, when it knows that the data type is string, then it will say that, okay, I here see a 97, but I shouldn't treat it as a 97. It's a string, so I should print a. And then how can I know it? Well, we have this ASCII character. It lists all these values, like 65 means capital A, 96 means dash, or 93 means square bracket, everything. Every character is listed. Then when I say, okay, how can I compare strings then? It allows me to compare strings. Like is red greater than blue? When we ask these questions, what is happening is actually, it is comparing those characters' ASCII values. But you might think it in this way also. Like when you open a dictionary, we actually also do this comparison. Like, which word exists before red or blue? Okay, so we lexicographically B comes before R, so that we can say, okay, B should be in that page, or R should be in the following pages. So we are also doing this. It is very similar to what we are doing with the dictionaries. So basically it compares, okay, is R, the ASCII value of R, is it greater than B or not, okay? And then if it is greater, we can check it again, go back to here, and then find lowercase r is 114 and lowercase b is 97. So is 114 greater than 97? Yes. Then it stops here. It doesn't need to check the other characters because the first letter is already greater, so that it says red is greater than blue. But what would happen is if I put here R also, maybe I say, okay, I don't know, red or road, okay? Then what will happen is, okay, we can also, I'll change it also here. Let's also make it here, change it. Then they say road is greater than red. What happened is, it first compared R, okay, they are same. So let's move to the other character, O and E, which one is greater? Then it'll say, okay, O, again, we'll go back to here. Normally it follows alphabetical characters, like the lowercase O, 101, and E is 101. One of them is 101, the other is 111. So O is greater, that's why road will be greater. So basically, yes, we are just doing comparing still numbers. But you have to be, need to be careful about it. Like if I write capital red with capital letters and red with lowercase letters, then actually it also means different. Like in dictionaries, we won't have this kind of restriction difference, but here we have, because their ASCII character values are different. When I run it again, then it'll say red with lowercase letters greater than with the uppercase letter. Why is that? Because uppercase letter values have lower ASCII values than the lowercase letters. So basically, yes, it is case sensitive also. It doesn't check the meaning of it. It doesn't check if, okay, this is R, this is also R, but one of them is uppercase and the other one is lowercase. It also means anything, something. And also you might say, okay, what will happen if I have red and red here, but I have some more letters here, like this is like a reddish letter. Then what will happen? I'll also make it same. So which means that the first letters are same, but this has only some more letters in that, okay? So again, I have to change my message to see that. So let me also convert it to this. Then radish is greater than. So the longer one will have a greater value. So this is also, you might think about it. Then you might ask, okay, Professor, do we really have to memorize these numbers? No. But you just need to know that what we are doing and so on. Thank you for your attendance. It's 10:50, so I should stop. This is the class for today.